So hello guys, I hope you are having a wonderful time right now. Maybe you're not having a wonderful time. Why? Because you are right now worrying about the upcoming test for the ECA. So in the test, the topics that we covered, one of them is RCL circuit. And in this video, I'm going to somehow help you with your study by showing you how to answer a certain question example, which is from the past year from 2020 and 2021. So let's get right into it. So the question here gives you a circuit, the circuit which of course is going to consist of inductor here and the capacitor here. First you want to analyze the circuit and understand what elements exist in the circuit itself. So there's the 9-volt battery here, and there are resistors here, and also two switches. So the switches close for a long time, and then both of the switch open at t equals to 0. So now you understand that the action that takes place here will result in the circuit being freed from an independent source. So after t equals 0, the circuit will no longer be exposed to an independent source. So therefore, you could say that this circuit here will undergo a natural response. And it is a series circuit. This is important because the inductor is in series with the capacitor. In parallel circuit, you will have somehow a different solution to the problem. So let's get into the first question. Of course, when you come upon an RCL circuit, it will ask you to determine the initial values of the variables of the circuit, which is going to be IL node, which is the current that goes through the inductor, VC, the voltage of the capacitor, and DIL over dt, also dVC over dt, at t equals to 0. So at circuit t less than 0, you know that the switch has been closed for a very long time. So if the circuit remains at a current state at a certain state for a very long time, you can therefore open circuit the capacitor and short circuit the inductor. And your equivalent circuit at t less than 0 will somehow be similar to this one. As you can see, I've closed the switch, I short circuited the inductor and open circuit the capacitor. So now you can easily find the IL and VC node. So let's find IL node. So first of all, you need to understand which part of the current is IL node here. So as you can see here, there's resistance here and two resistance here, and the current that we want to find is the current that flows through the 2 ohm resistor. So first, to do that, you need to find the overall current that flows through here. Then you can do current divider to divide the current between 5 and 2 and find the current that flows at the 2 ohm. So to find overall current, of course you're going to need to find the equivalent resistor first. So this circuit is quite simple already. As you can see, this one is parallel with this one, and this parallel system is series with 5. So you just put in the equation here, and you get the equivalent resistance equals to, of course, 45 over 7 ohm. So just use the overall voltage of the circuit, which is the V source and 9 volt, and you get the answer, which is your total current is equals to 1.4 ampere. And I want to remind again, this current here is not the current that we want to find, because IT is actually the current that flows here. This one is IT, and we want to find the current I total, and we want to find the current and the inductor here. So you can just do current divider, which is the formula, add any other resistance over the total resistance there, and times with the overall current, which is the current total, and you get 1 ampere. So if you've understand up until this point, then I congratulate you. So let's move on to the VC node. So to find VC node, here that you can prove it by KVL. You can find that the voltage at the VC here is the same as the voltage at 5 and also 2 ohm. So to solve this question, first you want to combine the parallel resistor. So this one could also be drawn as this one. So there's 5 here, and the resistor here is going to be the combination of the parallel resistor. So it's going to be 10 over 7 ohm. So now you want to find what is the voltage here and what is the voltage here. And the voltage here is going to be similar to the voltage that we want to find, which is the V capacitor node. So just use voltage divider, which is quite similar to the current divider, but the formula is somehow quite different. You want to take the resistance there per the total resistance, and then times the overall voltage. It's going to be 2 volt. So here you get your initial values for I and V. So far so good. So next up, you want to find the value of the derivatives, which is dIL over dt naught and also dV capacitor naught over dt. So for this one, you need to start to imagine what the circuit is going to be at t equals to 0. So let's go back here to this circuit here. So at t equals to 0, the circuit opens. So you will only be left with the middle circuit here, which is going to be equivalent to this one. I've drawn it for you already. So why it is important to make sure that you use this circuit is because in the formula that you are going to use, you are going to use the value resistance at the circuit t equals to 0 and not the previous circuit. So when you find dIL over dt, first up you need to know that this is the formula to find the answer. Now you need to memorize this formula, and I think it's not given on the test. So your resistance here, your I0 and V0, your I0 and V0 you are going to use the same that you find earlier. Why? Because in an RCL circuit, the current and voltage cannot change abruptly. So at t equals to 0, it's going to be the same as the steady state at t less than 0. So you just use the value that you find earlier lah. So this is the value here, 1 ampere, 2 volt. And the resistor, remember just to use the circuit at t equals to 0 and not the circuit at t less than 0. And here the resistance is 5 ohm. So you get the inductor value, you just put in the formula. And be sure to not miss any signs and operations here, and you will get negative 14 ampere per second. Don't forget the unit here. So to find dVc naught over dt, you are not going to use the same formula. It's a different formula, and I just want to give you a quick derivation of the formula. So it is actually from a capacitor formula, which is Q equals to CV, and you differentiate both sides, and then you get that I is equals to C dV over dt, then just do a little bit of rearrangements, and you get that dV over dt is equals to I over C. So the current that you're going to use, of course, the current that flows through the inductor here, which is IL naught, the same as this one here. You just put in the formula along with the capacitance value, and you will get 8 volt per second, and don't forget the unit again. So these are for the initial values that you will find. And even if the question don't ask you for this value, in solving an RCL circuit, in the end you will need to get this value right here to solve the circuit. So let's move on to the next question, which the question asks you the type of response of the circuit. So I told you already that the circuit, generally it is a natural response RCL series circuit. And the response is going to be divided into 3 categories, which is overdamped, critically damped, and underdamped. So these are the conditions in which you want to find and determine whether it is among these 3 responses or not. So of course you need to find the variable, which is alpha and also omega. So alpha here is of course your damping factor, and then your omega is resonant frequency, if I'm not mistaken. So this is the formula. And remember, this only applies for series circuit. For parallel circuit, the formula is going to be just a little bit different, but that difference is enough to make you get wrong on the question lah. So again, this is for the series circuit. So this is the formula. Just use the resistance earlier at the circuit at t equals to 0, which is 5, and just put in the value of the inductance and capacitor into the formula itself. So you will get your alpha is equals to 5 Nm per second, and your omega is equals to 4 radian per second. Now I know that the unit here sounds weird, but that is the unit, and make sure to write it. So now you just compare the alpha and omega, and you find out that the alpha is greater than omega, which is 5 greater than 4. So therefore, you can know that this is an overdamped response. So in solving overdamped response, you know, the equation is the simplest out of all the response here, which is like I've written this one. But we will use this on the next question, which is solving the equation for the current and the voltage. So let's move on. So let's find ILT and VCT. So to find this, first you need to write the equation of the variable itself, which is going to be, since this is an overdamped response, like I've told you earlier, it will be A1 ES1T plus A2 ES2T. So to complete this equation, there's 4 constants that you need to find, namely A1, A2, S1 and S2. And first you need to find S1 and S2 first, which is the root of the characteristic equation. So this is the given formula, and you could see that it is similar to the quadratic formula, just it doesn't have the per 2 here. So you get this formula plus minus, so there's going to be 2 value. just put in the value, which is 5 and 4, and you get that your S1 is equals to -2 and S2 equals to -8 Nipper per second. So you get S1 and S2, but now you need to find A1 and A2. So to find an A1 and A2, you need to do simultaneous equation. So how you want to get the two equations that you want? You need to compare and use the initial values that you found in the first question, which is I0 and di0 over dt. So how to do this? First, you need to, of course, write the value so that you won't, maybe mistake it for any other value, and you compare it with the equation of the overdamped response of I0 and di0 over dt, which is as shown here. Now just put in the value of S1 here and S2 here, and you'll get two equations, the first one and second, which is going to be in terms of A1, A2. So therefore, you can solve this. You can use your calculator. You can just solve it manually. This is a simultaneous equation. So you find out that your A1 is equals to -1 and your A2 is equals to 2. So you get all the four constants there and just substitute it into this equation here, and you get the final answer here. The A1 is -1, A2 is 2, and S1 is -2, and S2 is -8. So this is your equation for ILT. So if you understand up until now, then it's good news, because this is actually all there is you need to know to solve the RCL circuit. But it's not over yet, because the question also asks you to find VCT. And finding VCT, if you know how to solve for ILT, then VCT is going to be very simple. Why? Because the V is going to go under the same response. So it will use the same alpha and same omega value, thus giving you the same S1 and S2, which is the roots of the characteristic. So you use the same value for S1 and S2, which is -2 and -8. And then the only difference here is that you are going to use the value of V0 and dV over T0 instead of using the current. So like you find the first question, you can backwatch this video to find the value. The V0 here is 2 volt and the V0 over dt is 8 volt. So just substitute it into the equation like this one. And then you get the two questions that you want in terms of A1 and A2 and solve it using simultaneous equation. You can use calculator, and then you found out that your A1 is equals to 4 and A2 is equal to -2. So very similar step in solving, similar to the ILT. So just substitute the constant in the equation and you get the answer is as shown here. So this is all there is for this question right now. So I want to remind you that finding the initial value is very important, and you need to memorize all the formula. And this is just for the overdamped response. And there are two other response, namely underdamped and critically damped, in which you might want to study for that too also. And I wish you the best of luck for the upcoming RCL test, and I give you 5-star and a smiley face, a sad smiley face, because I assume that the ECA test is going to be very hard. But don't worry, if you study hard enough, maybe somehow you can improve yourself from the previous test. So I wish you the best of luck. And don't forget to eat well and sleep well. And I guess that's it. Bye bye.